Oh no, I think you know what? I messed up and I got my.
When you go straight that way, toward the elevator, turn right, go straight down the hallway, it's on your left. Yep.
I messed up because my this is the new iPhone,
Oh,
and it doesn't have this. It's got the other thing, and I know I have the adjuster, but I didn't bring it.
Oh,
So
no.
much.
Shoot. I think
So
I have one.
you do? That has
Like
it'll
the-
hook to this, and it'll be flat.
Yeah. Do you want it?
Okay, cool. Cause then I'll give a.
Yeah, I'll grab it. The panel is down that way. It's right there. So, yeah.
Thank you. Okay, I'll make sure I don't leave with it. I'll make sure I don't leave.
Oh, you're fine. I'm sure I'll see you again if you do.
Oh, you're good.
I'm just gonna like high five and be like, "Hey, you're part of it." Like, kind of meet out. And then you can, yeah.
But here, I mean, so we were gonna just do a quick introduction of Flatiron and then give your mic.
Yeah, that'd be cool.
Are you
Very good.
moderating?
I'm sorry?
Are you moderator?
Yes, I'll be the MC. I can get this right.
If you need a chair, feel free to grab one from the classroom. Hi, everyone.
Hi guys, we're about to get started, so we can.
Hi everyone, welcome to Flatiron School. If you need your parking validated, please have them out and I'll be walking around and giving you stickers for validation. And then now I'm going to give our campus director, Christy, to tell you more about Flatiron.
Hi, welcome. We are so excited to have everybody here. So yeah, I'm the campus director here at Flatiron School. Just a little bit of information about us. We are a 15-week software engineering immersive in-person boot camp. So we teach people how to be software engineers. They come out junior level devs is what we call them. And we are licensed in the state of Texas and currently going through the licensing process to add a full-time data science immersive in-person program to our offerings here in Houston. You can do data science online already through the Flatiron School, but we are super, super excited to have that. Knocking on wood, that gets done quickly here in Houston, hopefully to start in our first class in the spring. We are so excited to have HEDS here. We love partnering with and working with HEDS, and I will send it to you.
Thank you. You guys are panel? You mind sitting down? Sorry about that. I didn't ask you guys. I'll do an intro. So can everybody see? I know there's a big, can everybody see? You guys back there? You guys are coding? Why don't you, if you guys want to move like some chairs over here, so we have, there's plenty of space here. So if you guys are not able to see, oh, there you go, Cedric. That's a better idea. Thanks, appreciate it. Yeah, thank you for having. It's a pretty good turnout today. This is about like 80 people or so. So that's what we expected. It was a pretty hot topic, so it's a cool. So now I can see you guys. Hey, how's it going? Now you can't hide from us anymore. So yeah, thanks for being here. I mean, it's wonderful. It's our first meetup of the year. Usually our first meetup is we have quite a bit of people show up because I guess they're bored from all the Christmas stuff and Thanksgiving, and they just want to have something intellectual to see. So that's what we're doing our first meetup here in January. It's a wonderful space. Flatiron, this is like a third meetup here, so it's wonderful. I love being here in downtown. Although I could do without the traffic around here, so that's good. So what's happening with HEDS now is we're just rolling along. This is who's new here? Raise your hand if you're new. We usually get like 30 to 40%. Every meetup we have 30-40% of people that are new, and then we get those that are just consistently come in, like 30 or 40, and then we have like folks that hadn't been here for a while, but they like the topic and they come in. So that's pretty much what we expect from our meetups. So my name is Francisco, and I'm the president. And we have Charles here. Where is Charles? Raise your hand somewhere. There he is. Okay. Yeah, he's one of our board members as well. And another board member, he's actually flying tomorrow, so he couldn't make it today. So we have three board members and myself, and we do a lot of these meetups. We do have one every month, and we try to do them on Thursdays. We have 2 lined up for Friday and Saturday. February and March, not Friday and Saturday. Once every month, so this is going to be, we do about 10 of these a year, and usually we try to have them at fun places like this, where we have beer, and our beer and food is always free, so all of our meetups we've ever had, we've always had somebody has sponsored food and drink, so, if you don't have to suffer from hunger when you come here at night after work, so that's a good thing, right? So, great. So that's for the new folks that haven't come here before. So I want to get started with our meetup here. Since I'm the worst at introducing people, we're going to do an introduction in a little while, but this is going to be a forum setup. So what's going to happen is we're going to have a question that they've already got the questions. Our forum has already gotten the question, and they thought about it and on how to answer it through the weekend. And so they're going to answer that question, and then you guys will have a chance to ask questions yourselves, because this is a topic that has every meetup, practically every meetup that I have, somebody comes up to me and says, why, this is like one of the worst things, one of the most mystifying things that they have is what are companies looking for in a data scientist or a data individual, and what am I missing, So I think we have a lot of folks here that are sort of in that space. So can somebody raise your hand? Who's recruiting right now? Who's recruiting for data scientists? So, okay, cool, see? So you guys that are data scientists looking for a job, just make sure you go up to these guys and make sure that you ask them questions and bug them. Maybe you can buy them like some dinner after this or whatever. I think there's a flying saucer, you guys. Maybe they'll buy you something, I don't know. But that's the way it happens. But yeah, connect with these guys and go ahead and, you? Yeah. That's okay. These guys have a big budget, so you can take 20 of us. So yeah, it's more beer for you guys, so great. So this is something that, we're gonna try and do. We did a forum last year with Women in Tech when the Grace Hopper conference was here, and it was wonderful. We had a lot of people that asked a lot of questions. How to be, being a woman in tech is a little different than I thought I anticipated. So I learned a lot in in that meetup, and it was a wonderful thing. So we actually have it on live stream, so, and on YouTube channel. So if you guys want to check out that forum, it'll be here. So, well, that's enough for me. I could talk about this about another 30 minutes or so, but I'm sure you're not going to hear it. So we're going to get started. Here's our panel. So they're going to introduce themselves, and then we'll get started with some of the questions.
Hey everybody, my name is Graham Gansel. I work for a company called Expiro. We are a full stack software consulting company, and we have people all over the world, small teams all over the world, so that we can interface with our clients who are also all over the world. I run the data team for Expiro, and though my team is a subset of the full team, I think a lot of the answers you'll hear from me tonight are focused on integration of teams, specifically data science and data engineering with the rest of the org. So I think it's really important. My background is quite technical. I am a data scientist, hands in and out of the code almost every day. So if you have any deeper technical questions, I'm happy to field those after the event as well.
Hi everyone, my name is Sachin Padhe. I work for a company called Infosys. I work with Infosys Consulting. Infosys is a company which is global. It's present in 65 countries, and it focuses on consulting, technology, and outsourcing. So I am in the consulting group. I primarily work in oil and gas. My background is business. I did my MBA and then worked in business, banking, and then consulting now, and then through consulting different streams. But I closely work with data scientists because we work on a lot of data science projects. And although I'm not a data scientist myself, I'm on the border of data analysts, but we do hire several data scientists whom we work with. And sort of we are the bridge between the data science folks and the clients who are looking for business answers. So looking forward to answering any questions related to hiring and from the business perspective as well as to how we work with data scientists to solve problems.
Hi, Luther Birdzell, founder and CEO of OAG Analytics. We're an AI platform exclusively focused on upstream oil and gas. My background's in electrical engineering. Spent the past 20 plus years in the software industry, focused on building systems to make data more valuable to subject matter experts. Front half of my career, I did that on a consulting basis, touched numerous industries, including semiconductor manufacturing, medical manufacturing, insurance, finance, and a bunch of others. Through that period, met the founders of my last company, and those guys had built the test harness for Enron's online trading system. It's basically test automation for large-scale headless systems. And we got together, figured out that there was a market opportunity to take this technique that we used to call mocks and stubs. Basically, it's writing specialized code to create kind of replicas of data center assets. But for example, we worked with a bank that had a mainframe that went down 4 hours every day. When that mainframe went down, all of their testers came to a grinding halt. To make matters worse, they never knew when it would go down. So we created a self-service capability that enabled virtually anybody in an organization, or at least in an IT organization, to create these data center assets that save people huge amounts of money. That was an instrumental learning. We were acquired by Computer Associates in 2011. It was a great exit, 12.5x return to our Series A investors. And coming out of that experience, I knew I wanted to breathe life into a new business. It was very clear to me that AI and machine learning and the cloud were instrumental ingredients for adding value to data. And coming fresh out of this experience with taking this thing that the world viewed as only possible with specialized programmers and democratizing that, made it available to everyone, the vision was to do that with AI. So our platform is self-service. It enables geologists, geophysicists, and petroleum engineers to develop world-class artificial intelligence, which we define as just simply teaching computers to do things that traditionally, or we think of generally as only humans are able to do. Machine learning is a part of it, but not required for every aspect of it. And to do this, our users have to be able to bring data together and QC it extremely quickly. They then need to be able to train world-class machine learning without writing code. There wasn't a buzzword 5 years ago. The buzzword today is AutoML. And then to be able to do meaningful things like build maps that show companies where applying these insights are going to generate material value and where they're not. So we're actively hiring. We tripled in size last year. Looking to triple the business again this year. And we're trying to hire 10 people as fast as we can find 10 amazing people.
Awesome. Thank you. Okay, I'll just keep one here, and then so our first question, and we'll go this way from left to right, is what do you look for what is your hiring process when you hire a data scientist or a data engineer or somebody in analytics in your company?
Sure. So my experience is slightly different than many larger companies insofar as a lot of the data scientists and data engineers, and in fact many of the technical people we have working for us, are a lot more senior than sort of entry-level employees. And the reason specifically is because we work mostly for clients in so-called complex domains like oil and gas, where you need a certain amount of domain experience. And one of the biggest assets you can bring to the table as a new data scientist is that domain experience. So if you're working in oil and gas now, and you'd like to transition into the data science workplace, one of the best things you can do when you're marketing yourself on the job market is to highlight your domain experience and generalize from each one of the specific points that you worked on in your field. So for instance, just a case example would be, if you were a geophysicist working in the oil and gas business for 10 years, but you did some coding and you found yourself transitioning into more of a data science role and wanted to step into that field full time, on your resume and in calls and in-person interviews, I always find the most fascinating candidates to be the people who would highlight, let's say in the case of geophysics, their spatio-temporal modeling capacity. So for 10 years I worked on seismic data, and modeling is important because we used synthetic data and we used real data, and we tried to match those things up and figure out why they were different. It's just as important to do this as an entry-level candidate as it is as in a more senior position, application position. In the senior level roles, you should be marketing yourself, in my opinion, as a specialized data scientist. So now that you have some career experience doing data science related activities and specific tasks, you're going to want to focus on the types of models or processes that you're most familiar with. So maybe that's something like recurrent neural networks. But all of us, I'm sure you'll hear, read a million resumes a day. And the ones that stand out are the ones that focus on some sort of specialty, where that specialty is driven by a passion for the projects you've worked on in the past.
So Infosys has two broad groups. One is data and analysis, which is hardcore data engine and has all the three categories of people, which is analysts, scientists, and engineers. And then Infosys Consulting also has data scientists, but it has more of data scientists and data analysts, more of data analysts. In general, just like any other job, here we focus on 5 main areas, which is domain experience, skill, then your passion, your power of reasoning, and your communication. And within that, so in terms of domain experience, that's an absolute must. As you just pointed out, the first thing we look for is domain experience, especially for people who are mid to senior. People who are starting out, we would like to generally see where the person is inclined, because accordingly our streams can then focus on that particular hire. In terms of skills, in the first sort of rounds, we just try to sense or just get a feeling of how skilled you are at a particular package or a particular way you analyze problems. And then as you go further, the complexity increases in terms of that testing. In terms of knowledge, we look at, domain knowledge as well, but apart from that, even pure maths and stats, there's there's an emphasis on maths and statistics and your understanding of that. Reasoning, many a times you need to actually, you may not be fully aware of the particular function, or you may have slightly sort of experience or knowledge on the periphery of a domain. So you need to use your reasoning skills to tackle the problem, understand the problem, and define the problem. And of course, passion. You have to have a lot of passion to get stuff done, because as you all know, you could just end up going in loops, trying to solve a particular problem, assuming you have defined it correctly, but you have to have the grit and the passion to get to the depth of solving it and getting an answer that satisfies the client.
All right, so from the consulting side, we have a view of data science where there are not enough. There's a global shortage of data scientists. Everybody's heard that. To me, that means there aren't enough people to write code for all the subject matter experts in the world who need to apply this, or whose companies, whose businesses can benefit in a big way from it. Kind of look at the space. We segment in two ways. We've got the consumer side. This is search, social media, retail, entertainment predominantly. That sector is categorized predominantly by these massive, massive volumes of these trivial decisions. Google, great example, they did 3.5 billion searches yesterday. They extensively use AI and machine learning to recommend the links and the ads that are presented following any given search. That environment, they can A/B test all kinds of different algorithms, all kinds of different approaches very, very quickly at a de minimis cost. Take an oil and gas company, absolute other end of the spectrum. That company, a pretty big company, is maybe drilling 100 wells this year. The median cost of those drilling completion cost of those wells is about 8.5, let's call it $10 million. It's $1 billion capital program that comes down to about 100 decisions. Nobody in their right mind should let a computer completely automate making 100 decisions. Like, you can't, it's too expensive to A/B test that. So that's a very different domain to apply this in. And to trust the insights when you can't test them really cheap requires transparency and it requires control. The subject matter experts need to be able to define exactly what data is going to be used. This is which columns from which data sets, and about every row is QC. Then they need to be able to have a lot of visibility into the machine learning, enough to really be able to trust it, put their jobs and their reputations and tens to hundreds of millions, if not billions of dollars on the line behind the decisions. Before they can do that, they need to do something meaningful with those models, and that's usually running simulations on them, and then making sure the simulations are bounded within the realms of physics, first principles, and experience, and that the results are interpreted similarly. So for us, there is absolutely the traditional data scientists, work with the companies, basically train our customers. Our front line with customers have PhDs in geophysics, PhDs in petrophysics, advanced degrees in petroleum engineering, have done multiple budget cycles with a company like the companies we sell to, predominantly North American unconventional focused operators, so they can really interact with a peer basis on the folks that they're training how to use our software. Our hypothesis on the platform that's going to create the most value for this industry, and we think this model scales to others as well, is one that doesn't require writing any code. So wrangle the data really fast without writing any code. But to have a platform that you can do that, people can do that with, requires actually writing a lot of code. So we have software engineers who have data science knowledge. You can't build a data science platform without knowing some of this, but they don't have subject matter expertise or nowhere near the same extent in oil and gas. So we recruit for them differently. The best recruiting is always in network. If you have friends who have data science jobs at companies you'd like to work for, ask them for help. If you don't, come to meetups, meet those people, do other networking, meet those people. Networking is the best way to get in. It's really, really difficult to get a job by just sending a resume in. it's tough to differentiate. Certainly not impossible, and I'm not saying don't do it. But if you can go in through a network, it's always better. And then decide, do you want to write code for people? Do you want to teach people how to use codeless tools? Or do you want to work on building the tools that enable people to scale these enabling technologies without writing code themselves? We think they're all, I personally have done a little bit of all those. I enjoy them all, but absolutely agree with what's been said about passion. It's just too hard. It just takes too long to do this for a paycheck alone. Quite frankly, life's too short not to do things we love.
Thank you. Anybody have any questions? Anybody have any questions? You want more beer? So you guys come up.
Thank you very much. I worked for oil and gas industry 6 years in the past. I have a master's degree in petroleum engineering. Right now, I just started to transform my career to data science. I already started taking an online data science. They call it career track. I just started right now. It maybe take a couple more months. I just wondering, my question is, so you said like here, like, I'm sorry, so you said here you still like take the hiring process, like meet ups to know people, get connect, network is very important. But for oil and gas, I know it's very important because I've been in there for 6 years. But right now, I think tech. The reason why I want to get into tech, I want to know. Because you're tech, right? You can find people more efficient online, like LinkedIn or other online platform, or it's only like social, or it's like any other paths we can get in touch with a recruiter or the company they're hiring, or like GitHub, we post and record those stuff. So I'm just wondering any other things except Top Meetup, because I'm so busy right now. I keep working on my code. I don't have time to come out social, right? I just wondering if that.
Sure, so there's definitely a balance, but the good news is you've already networked. My email is luther@oaganalytics.com. Feel free to forward your resume to jobs@oaganalytics.com, and we've met. So, look, my experience has been networking is always the best. It's certainly not the only thing. So do what you can with the time that you have.
Do you guys look at GitHub when you hire a data scientist or whatever?
We do. For oil and gas, there's a lot of LinkedIn. We don't see a lot of software. We don't see as many software engineers on LinkedIn. But look, it's really inexpensive and quick to post. And usually just apply for things online. Use that to your advantage, right? Take a big data approach and go and address a lot. Submit your data. Take a big data approach to it, right? Do a lot. Automate it. Write some code. Script it.
So we have acquisitions online on our website, and we do definitely monitor them closely, especially if the demand for those particular positions is high. So one of the things you could definitely do is, look at websites and then typically reach out to the people working in that company to get the name of the recruiter and then get directly in touch with the recruiter through LinkedIn. So that we've always wanted to be very effective.
Yeah, we actually do look at GitHub and other portfolio types of work extensively. Again, these positions that we're hiring for are a little bit more senior than your basic bootcamp capstone project on GitHub. But it is important to showcase your work as much as it is to showcase yourself. Networking is the ultimate, as Luther said, but there is a lot of value when applying for a technical position in having some portfolio that you can show to recruiters.
We have another question here.
Hello, guys. So my question is this. What's more of a priority? Do you need to learn the software, learn the languaging programs like Python or R, or do you need to learn the fundamentals like how these algorithms work? So learn your statistics, calculus, and I know both of them go hand in hand, but what do you think is more of a priority? And if you were to do it again, what's your process throughout, from maybe you have 1 year to decide how I'm gonna get a data science job, what should you do first? Either get the basics done or learn the software.
The difference between data scientists and software engineers is that data scientists know more math. And know less code, probably. So you have to be able to code, but you need to have a very solid grounding in the mathematics. You need to know why the things you're building are generating the answers that they're generating. That's a little bit different than standard software engineering roles. So I would say focus on the theory more if you're applying to be a data scientist than if you're applying to be, let's say, a data engineer or a software developer.
Yeah, what I would say is determine your focus area first. So whether you want to be a data analyst, a data scientist, or a data engineer. So typically, if you're a data analyst, then you need to understand a little bit of coding. You need to do a lot of visualization. You should be able to communicate well about the business problems and so on. And of course, as you move towards becoming a data scientist, you need to be able to dabble in predictive analytics. Not dabble, start dabbling, but be really good at it. And of course, ideally, if we were to find a combination of these three skills in one person, we would just grab that person right away. So if you do want to be in this field, at some point you want to think about mastering, or at least near mastering, all these three areas: engineering, science, and analysis.
So I'm an engineer. I learn with project-based stuff faster and kind of more effectively than other ways. The way I've learned really all software, including data engineering and kind of machine learning engineering, it has been by just picking a project, getting a data set, digging in, at least for the first pass. And then as I start to get some weird results, and I'm working with data on a problem that's actually of interest to me, something doesn't make sense, then it's kind of start going down the rabbit hole, peeling back the onion there. And it was just a very iterative process. That's also kind of fundamental to how we train our team. Subject matter expertise is an oil and gas experience for our data science, for the customer-facing side of our data science team is essential. But a lot of the other things can be learned. And I do agree that data engineering is a standalone role. Training machine learning models is something that is predicated on data engineering. So if you're really starting from the beginning, you got to get the data cleaned up and in order first. Learn that. If you love that, maybe start as a data engineer. There are a lot of great, really low-paying jobs. Data engineer, working for a company with interfacing with data scientists every day is a great way to learn more about that from experts. And again, I'll learn faster from an expert working on a project than I will, kind of in a vacuum on my own.
Any other questions?
Hi, my name is Valentina. Two of you talked about geophysicists. I know there are a couple of geophysicists on this table. So what would you say would be the one of the three things that you would recommend a geophysicist do to enter the field of data science?
All right, I'll start. So the reality is most geophysicists coming out of programs, especially with masters or PhDs today, already have significant exposure to neural networks, have been used for inversions extensively for a long time. Learn how to code in Python. Maybe learn how to go from a data set to a trained machine learning model in Python, and be able to explain in plain English how it all works to another geophysicist. If you can check those boxes, please give me a call.
Will you give the phone number?
Yeah, my cell phone number is 832-544-4791. Call, text, anytime. I'll give you a card after.
You want to talk about it, or?
I'm not brave enough to give out myself. I will say that geophysicists have a leg up on a lot of domain experts in the oil and gas business because you're quite quantitative. You do need to know how to write code. That is the thing I find most lacking in the G&G biz. Potential applicants coming to us with a lot of domain expertise, but very limited coding expertise, is sort of an untenable relationship. We just, again, you need to be able to get things done, and if you can't do things fast and correctly, it costs too much.
Yeah, and just to add to that, as a general rule, it's important to be able to communicate, right? I mean, whatever you analyze and whatever you find out, you should be able to communicate that in a manner that doesn't appear to be coming out from black box. Because ultimately, many times I've seen that whenever, especially I'm dealing with clients who are on the business side, they are more interested in the outcomes. And they sort of very much rely on their data scientists to vouch for the correctness or the accuracy of a model. Now, we always know a model is never right, it's always an approximation, but that's the confidence that they have inherently. And sometimes they might get into the depth and they might try to probe, and that's where things get really difficult, and you need sort of almost decoders who can go between the business and data to help understand what's the problem being solved.
Thank you. Yeah, you got a question?
Yeah, hi, my name's Joe. So this was brought up earlier. It's really expensive to do A/B testing or to test different hypotheses in the oil and gas field. And you brought it up, $1 billion a year in CapEx for an operator if they're doing 100 wells. But on the other hand, we have a significant body of public domain knowledge that's out there that's published by all the different states. What have you guys seen as far as operators, companies, consultants trying to leverage that source of public information to drive actionable insights for people that are working in this field?
We have some folks from IHS here. Anyone from Drilling Info, RS with Matt? Okay. Anyway, public data, its value changes from basin to basin. So in North Dakota, where the state requires that liquids are reported on a per well basis, there are tremendous insights that can be derived from the public data. Now, North Dakota, the NDIC, North Dakota Industrial Commission, does not require all of the details about a completion to be disclosed. So you're not going to get a lot of insights into cluster spacing, per cluster, and the size of the purse and whatnot. But that said, Bakken is a great example of great liquids insights from public, basin-wide liquid insights from public data. In Texas, the gas data is reported per well, but we have the allocated production issue, where basically production is reported per lease, and there's just not a great way to trace it all back per well unless you have access to the proprietary data there. We have done experiments with customers in both the Permian and Eagle Ford, where we trained models using their proprietary production data with the public completion data from IHS, DI, Railroad Commission, whatever. Those models didn't have as many insights, it wasn't as robust a data set, but there were material insights that came from that. So if you are looking to do data, if you're working for an operator and you're doing data trades and that kind of thing, the most valuable thing you can trade for is the production data. I guess I'll leave it. That's probably plenty of time on that topic. Does that answer your question though? Yes. Okay.
Yeah, another question is, there is a difference between being a software developer and software engineer and a data scientist, right? Sometimes recruiters and companies like to put both of them together, and they find out very quickly that a data scientist is not a pragmatic programmer. They're trying to solve a problem, they go through a process, but it's not software development or software engineering. Do you guys separate the two roles? How do you do that? Or do you try to find a data scientist that has a little of both or both of them together? Or? But how do you handle that type of application?
If we find someone like that, we'll grab him. But typically, you're right. Skills are distinct and different. So we make sure while working with our recruiters that we outline those very succinctly as well as very clearly. If you see our postings on our website, there are specific postings for data scientists and data analysts that are different from people who actually know very hardcore software skills.
So I'll say that there is no data science without software development. The data science action doesn't happen without a team. Where you can write all the Jupyter notebooks you want all day and come up with harebrained schemes, you cannot generate business value without having a robust team of skill sets operating on the same problem. That team, in my view, is composed of software development, data science, data engineering, and then sometimes data analytics, or data analysts. But you need to have all those skills operating together. And that is one of the most difficult operational aspects of data science at scale and data science in production. But it's somehow you have to make your team figure that out.
So for us, they're very different. The only thing everyone has in common is they're incredibly intelligent. They work really hard, and we all get along, I guess. The software side, kind of piggyback on this a little bit, to deploy, AI, data science, machine learning, whatever you want to call it, systems, really into production that real companies are going to use to optimize large amounts of capital, requires a lot more than just a prototype working. More or less, the value proposition of cloud data storage is more expensive than storing the data locally in most cases, but the compute is a fraction of the cost. And especially our approach, which is kind of spin up like hundreds or 1,000 computers in AWS, deploy a different configuration of different algorithms to all those different nodes with the same data set, and in about 5 minutes objectively measure which configuration of which algorithm produces the most accurate model for a given data set. That's kind of the foundation of AutoML. That's not the right approach for everything, but it's what we do. To use all the different pieces in the cloud and have like auto-scaling infrastructure with the right security and tying all those pieces together requires like a village of specialized software engineers with DevOps people to working with them to tie it all together. That team doesn't, that software, that's like hardcore, real deal software engineering, and it's massively complex, and the people who do it love it. The data scientists don't write as much of that kind of code. They do more, Jupyter notebooks, kind of prototyping things, and using our platform a lot. So at least, what my experiences were, they're very different roles, they're both wonderful, and you don't create all the value without both.
Anybody have any questions? Okay, quite a few.
Hi, so I just have one more question regarding the topic, which is, so if you have two people who have more domain knowledge and less coding skills, and a person who graduated with masters in computer science who has high skills in what you're looking for but very less domain knowledge or no domain knowledge, whom do you prefer, and what do you suggest for computer science grads that have more technical skills but less domain knowledge?
So again, when we actually talk to the candidates, it would be those 5 things that I mentioned earlier. It would be a combination of that. It's not one trumps over the other, right? But what you say is right in terms of screening. So again, it depends on, in our case, it depends on the requirements that we have when a particular project comes up or what the pipeline of the projects is. So in case if it's, let's say, a domain which requires at least a basic introduction or understanding of that domain, then you would prefer domain. because clients are very picky nowadays. They want to see some experience rather than someone fresher interacting with them. So that's our viewpoint.
So we're gonna go to the flash round because we have so many people here and we've got a lot of questions. So yeah, if you ask a question and we have one person answer it here instead of all three. So just to get through all of your questions, because I know a lot of people have some. Anybody else have questions? Yeah. Oh, okay, sorry. I'm gonna hit this spot because I haven't hit these guys. You've been hanging out here.
Cool. Let's say that we, congratulations, you have funding to hire a new data scientist. What does that process look like from a screening perspective? And I guess kind of how do you screen candidates effectively? Is that project-based or just general kind of skill set, content-based?
I'm holding the microphone and I can't see you, so I'm walking over here. Hey. Yeah, it depends on what the role is, and it depends if there's a specific application for that new teammate. But the application process is pretty, in broad strokes, is pretty contiguous across the data science industry. It goes something like this. You get a phone screen. Are you a real human being? You get a technical phone screen. Hey, do you know anything about what you claim you know stuff about? Then you get some sort of test, which can be something like a suite of logic puzzles or stuff like that. Personally, I never do that. I think it's impractical. Or it can be something more like a data science capstone project that you hear about from the data science boot camps. So this is typically, 24 hours or a week or something. Here's a data set, here's some questions, or sometimes the interesting tests are you don't have any questions, just generate some cool insight. And then you have the in-person interview. And generally in the in-person interview, which is usually a day or possibly several days if you're interviewing for a more senior position, you go into the company, you demonstrate your capacity to reason, communicate, and sometimes you have something like a pair programming exercise when you're in person, and it's an offer after that generally. Generalization, but that's typical.
Do you guys ever look at Kaggle competitions or hackathons that people have participated on? Is that something that is valuable to hire?
Yes. Similar to the comments that were made about contributions to open source projects, a la going through GitHub projects and whatnot. Contributions to open source projects are one of the greatest ways to, that's the software engineer, data scientist, equivalent of like an artist's portfolio.
Anybody here, you have a question?
I'm super new to the idea of data science. I don't have any coding experience. I'm trying to teach myself online right now. Do you have any opinion on whether I should go back to school for something boot camp, like Flatiron for instance, or whether I should go for a master's in data science?
So here's my view, and I'm slightly biased towards that because one of the things, if people want to start in data science and if they don't want to go to school full time, then of course going to school part time is a great idea where you upskill, right? But apart from that, you could also look at consulting, where you closely, specifically work in a data analysis area and work with data scientists on a regular basis. So that way you understand the business viewpoint, and then at the same time in parallel, you're upskilling your data scientist skills, and then you can move into the data scientist domain.
Anyone here had a question?
Hi, my name is Rebecca. I'm currently a PhD student in data science. You said that maybe I can ask some technical questions, or maybe this has to do with the hiring process. So like from my academic experience of coping with the data analysis problem, sometimes the most difficulties we're hearing about is the data quality rather than the model itself. So like, like in some open source platform, or we can see that the results get pretty good, accuracy is pretty high, it's only because the data quality is very good. But actually in industry field, we have a lot of noisy data, or a lot of data coming from the traditional parameter-based method. A lot of models, they're not robust enough to learn to generalize the real model, but they learn some noise by themselves. So my curiosity that's in the real industry project, how do you cope with this kind of noisy data problem? Are you kind of doing more posterior analysis, or you go back to clean the data by yourself, or you're going looking for more robust models, something like that?
That's a pretty general question. Data is expensive, and in the oil and gas business, it is particularly expensive. And if you can balance human capital against data capital, you can generally come up with a correct balance in terms of investment as to how to correct for the bias that you're receiving in your models. And by models in this case, I don't necessarily just mean machine learning models or algorithmic models. I also mean human interpretations of data. Again, at this very high 30,000 foot level, I guess the answer is it depends. But many cases you can clean the data. Many cases you have to buy more data or produce more data. And in many cases you can invest human time, worker time, into the data pipeline process at some point to condition the data.
Francisco, if you don't mind, there's a concept I'd like to speak to you for 1 sec. So there's one other piece of this that I think, or we see making the biggest difference, because we come across this every day, and it's really then, it's at the confluence of physics and statistics. So if a model isn't able to generalize something, data QC, there's some things you can do there, but you're going to hit a wall. To get past that, and we've been able to move way past this in some cases, if you can teach that model physics, like for example, like well spacing, ultimately you're trying to capture the behavior of what happens when you stick more straws in the same milkshake. There's no single metric that captures that. Like the distance from like the wellhead to the wellhead doesn't do that. The diagonal distance between, or the distances between like the midpoints in the wellbore doesn't do that, right? But collectively in that data set, you're gonna have a lot of different things about the rocks, you're gonna have things about the existing wells, the wellbore, and it's possible to come up with derived features that can capture that behavior that will then generalize that. That's really where the art comes in, and where the subject matter expert data scientist is absolutely invaluable. Yeah, they can QC the data better, but it's really about being able to bring the physics together with the statistics to create a huge amount of value.
Thank you. Anybody here have a question? Yes.
Hi, I'm Krishna. I work as a data scientist in Academy Stores. So I had a question like how important is for a data scientist to know about data engineering, and what exactly you mean by data engineering when it comes to like, your company?
Anybody want to tackle that one?
Sure. So data engineering is essential for training models. Unless the data that the data scientist who's going to train the model is receiving is already pristine. Normalizing units would be one example of data engineering. Time series normalization. A lot of like production for oil wells is reported maybe per day over a calendar year, basically reported in calendar time. We want to normalize it though. We basically want to normalize downtime out of that. So if there's non-producing days, we want like blocks of 30 producing days, as opposed to just how much oil did we get in a given calendar month. Those are some simple examples, but then there's transformations you can do, right? So like anything that can be done, that can be undone, anything deterministic, and there's 80,000, 100,000 mathematical functions that can do that. There's numerous functions that can operate on text. There's specific functions to operate on location data, geospatial, other things that even then get specific for special data types, which become industry specific, like a well identifier can have 3 to 5 pieces of embedded information in the lower 48. Pulling those apart, using them effectively, all falls under the umbrella of data engineering, joining data, automating processes for filtering and identifying outliers, all fall under data engineering for us. Anything you want to add to that, Graham?
Yeah, I have a generalization here because we work with a lot of both of these types of roles. And that is, if you don't know how to do something, it's science. If you do know how to do something and you want to optimize it, it's engineering. And that is this distinction between those two roles in a very general sense.
Very cool. Very cool. Now, we do have some HR recruiting people here. To stop them from sending 100 resumes to hiring managers,
Only one of us gave out our sense.
what do you recommend would be like your top filters that you would tell folks to say, hey, this is what I'm looking for when I look for a data scientist and a data engineer, or anybody else, a data analyst or whatever?
Sure. For us, it is a suite of characteristics that are related to the principal day-to-day operations of each one of the roles. So for data scientists, that's things like modeling and heavy mathematical backgrounds. For engineers, that's things like a lot of DevOps experience and some software development experience as well. But the thing that I look for particularly, that I filter the most, and when we work with recruiters, this is what we advertise, is the data scientist is a translator between the business requirements and the technical requirements. And so we are only willing to entertain conversations with applicants who are capable of performing that task, so that those skills are communication and their adaptive reasoning, right? So if a CTO wants to extract some insight from their next well drilling program, a data scientist needs to be able to translate, I want more oil out of the ground, into a set of technical requirements. That's hugely important.
I want to go on a slightly different track and throw some light on what's happening in the consulting industry related to data science, especially, and this is especially important for freshers or who want to move to the data science field. So many of the consulting companies have bought intelligent platforms and they are now building intelligent solutions, or something called as prepackaged insights. With the vast amount of data available, they are putting together teams of consultants, analysts, engineers, and so on, and creating solutions that address problems. So then they can go to clients and say, look, we have a working solution. This is the insight that we are getting from generalized data. You give us your data, and then we will get a solution out of this application right out of the box, and in a pretty short time. So what that means is that given that there is A, data scientists are working in teams, B, companies are like ours are looking for people who have experience, but again, there's a shortage. So if you want to get into this field, you can participate in hackathons as well as start creating your own projects. There is open source software for coding. There are data sets available that you can download and use, and look at industry problems, formulate them, and solve them. And that's a perfect example of showing your work on your portfolio.
Hi, I'm Greg Capcular. I'm a petroleum engineer with many years of experience in the oil and gas industry in reservoir and production and reservoir modeling. And I have a master's degree in petroleum engineering, and I recently graduated from the data certificate program from UT Austin on data analytics and big data. So I'd like to move into the data science arena. And I'd like to work as a data scientist, but I'm a little discouraged because even in oil companies, the positions advertised state that they're asking for mostly, preferably PhDs or master's degrees in math or statistics, data science positions. How should I approach? I mean, should I just say I'm going to use the data science as a tool for my reservoir engineering work, or do I have a chance of actually working as a data scientist?
So if you want to work for an oil company, I would recommend applying for a petroleum engineer, reservoir engineering job, and they're more likely to hire you and will pay you more if you can apply machine learning to that role. Or find a startup or find a consulting company that specializes in data science and can leverage your subject matter expertise. But generally the the folks that the oil companies want to hire as data scientists we see are either way underqualified IT people who have just changed their title, or they're really advanced folks in data science who have masters and PhDs. But within an oil company, by the way, they're not as sensitive to hiring data scientists with subject matter expertise because they have asset teams. Like, the whole company, they have all these technical resources. So they're really looking for, a mathematician, software engineer to write code for their subject matter experts. Anyway, that's what we see out there. But any oil company today would rather have, given 2 petroleum engineers, they'll take the petroleum engineer, 2 equivalently qualified petroleum engineers, they'll take the one with the stronger data science background at least 9 times out of 10.
Anybody else want to tackle that one? No. Anybody else have a question? Yeah, right here. I didn't know I was going to have to exercise today.
Hi, for those of us that aren't from a oil and gas background, could you give a concrete example, end-to-end example of a data science project that you've been a part of or that your firm has been a part of?
Yeah, I mean, there are several such projects in different areas. One example could be in the procurement space. So basically, there is item master data that is used for procurement. And the item master, there's a company that had an item master data. They had the purchase information requisition records, and then they had the supplier catalog content. And the data was in such a shape that they were unable to link the item master with the supplier content catalog. And as a result, there were a lot of non-catalog buys that were happening. And so the compliance in purchasing was low. So they came to us with a question saying that through machine learning, can you build a model which can A, increase the matches between the item master and the supplier catalog content, and B, through human interaction, continuously using machine learning, increase the number of matches as you go along. So that's exactly what we set out to do. First, look at the data, clean the data, match the data that gives us a baseline match, and then build a model. That has human interaction and which includes supervised learning, and then go along the journey where we achieve almost from 5% match rates, we achieve almost 50% match rates. And the business outcome is A, increased compliance and spending, B, less cycle time, and then so huge wins in sort of data science projects.
One of the questions that I always get this is that data science or dealing with data takes a lot of creativity and they're really artists. Not only because data scientists dress really funky and listen to weird music, but also that, when you have things like not only a data set, you might have like a variable that is very familiar to another one, you can use a substitution variable, or mix another data set or another type of data into something and make it something that's valuable. Can you explain what creativity and all that, how does that work in your organization?
Creativity works differently between disciplines. Specifically in data science, it is the application of external ingredients to a particular problem. And I think this is true not just of data science, but of all science. So a world-class scientist is the one who can reason from the general to the specific, and the instantiation of like the kernel of that creativity is the ability to reach out from your head down working hard state to see the forest through the trees, pick out a piece of, in this case, data from a different domain that might have some impact. So for instance, we're working on the modeling the spread of influenza right now. There are plentiful data sets to model off of, right? You have 20 years of CDC data, for instance, and many people have done modeling just based on that data. But what if we could incorporate something like weather data, right? That's not too hard to extrapolate. or consumer spending. Maybe that has something to do with the mixing of peoples, right? So the application of creativity in data science is very often in the inclusion of extra domain information. And in the case of specifically deep learning, the greatest successes I see with deep learning in application are due to the application of various techniques in the literature on some problem set. You talked about the inversion of seismic data earlier using machine learning. So someone had the idea, let's use a domain transfer system, a generative adversarial network to invert this seismic data. That's weird, because up until that point, people had just been transforming cats into dogs on photos. So those are the two data science creativity tangents that I see often.
So generally, as we see it, there is creativity across the data science value chain. I mean, from a consulting perspective, it's data ingestion, data analysis, data insights, data visualization, and then actions resulting from those insights. So there is tremendous creativity involved in looking across this value chain and putting in all the pieces together. That's one. And then in terms of sort of artistic creativity, there's the communication piece, where visualization steps in. So you've got to be really creative in making sure that the message is clearly sent across from what the insights you're gathering. And that's where your visualization skills could come in.
Any other questions? Oh, let me get over here.
So you guys mentioned deep learning, and you might be seeing like on resumes many candidates having like commonly like deep learning experience or some machine learning algorithm. I'm very new to data science. So what do you think are algorithms or techniques that are not widely used that you think do better than deep learning techniques?
So I can't think of anything that's not widely used that performs better. But there's some big advantages to doing feature engineering and using that with engineered features with shallow algorithms over deep learning. Deep learning is fantastic for labeling unlabeled data. So if you have a photograph, right? Automating a process to label the pixel density and everything there, and then be able to match stuff up. Deep learning absolutely is the way to do that. But if you have structured data, think of like kind of spreadsheet of rows and columns of data, deep learning is very opaque. And if you're going to make especially if you're doing it for high consequence decisions, the traceability benefits that you get from using a decision tree, or even an ensemble of decision trees, which, look, a random forest is not as easily interpretable, but it's as a decision tree or a linear regression, but it is much, much more interpretable than like a 7-layered or any kind of neural network or something. So random forest, XGBoost are both in scikit-learn, part of the Python package. Learn how to train a regression first, learn how to build a simple decision tree, and then look at the Kaggle results and see which algorithms they're using, are winning the most of those. Random forest and XGBoost are two real good ones.
Thank you.
Hello everyone. Everybody's talking about oil and gas over here, but I'm a biomedical engineer and I'm transitioning into data science. So I'm also a recent graduate, so I would like to know what is the job scenario as Houston has the biggest healthcare facility over here. So just wanted to know how's the job scenario in healthcare. Yeah, because so I'm from oil and gas as well. I do know that we have positions for healthcare in Houston. Primarily for data analysis, not for data science as much. But I think a majority of them are more in the Northeast, Boston, New Jersey, and so on, and of course in California as well.
Additional. I have a couple of concrete recommendations, and I won't say company names up here because I haven't been endorsed. But there are, particularly in Houston, there are a bunch of bioinformatics companies, especially startups. And in my limited view of the space, there is a great deal of opportunity for data science techniques in the bioinformatics world. So that's somewhat related.
Cool. Anybody have any questions here? Does anybody else have any questions that hasn't gone yet? Okay.
Hi, my name is Liang Wu. As you guys have said, a data scientist requires many areas of expertise, like the domain knowledge, the coding, the math, modeling. But also, data science is a very new field. So I'm wondering, do you have a typical career path for a data scientist in mind? Maybe like, I'm doing data science now, and after 20 years, what I'm gonna do, that kind of thing.
I think that data science has a particularly interesting career trajectory, which is because of what I mentioned earlier, being a translator between business and technical requirements. I think that data science workflows and their peripheral workflows require even entry-level positions to have a very prescient oversight over whatever business problem they're solving, and that in 20 years leads to becoming maybe a CTO.
Yeah, so data science is not a relatively new field. It's been there in existence for a long time, right? But now it's coming into vogue because of computing power, availability, and so on and so forth. And I think the future is really bright in the next decade or so. Right now, companies are still in forming teams of data, data analysts and so on. The large corporations have already done that. But in the future, expect a department like just IT was several decades ago. There were the small teams, but now you have a CIO. Companies will definitely have a CDO that will be a standard term going forward. I mean, many companies do already have CDOs now, a chief digital officer or a chief data officer.
Cool.
So I'll take this real quick. I don't see it as any different than a software engineer or any other technical job. You start off early in your career, in a technical role, you learn how to do that, and there's people who love that, who do that for decades. There's people who love that and move into management, and then find some balance of doing the technical work and managing technical people. And then there's those of us who sell out and go into go into executive management.
You have a question here?
Yeah, hi. So bear with me on this, but let's say, so I don't have any coding experience, but as, in the future, what I want to become, I'm trying to define that. So say I have a few puppies, and one of these puppies is called data science, the other puppy is called data analytics or, analysis, and data engineer. And there may be a few others, but I was just wondering for you guys, what would be the top dog?
Yeah, that's a good question, and that's a difficult question. For us, it would be depending on what demand we have from clients and the type of projects. So really, it could vary at different levels of time. What I would say though is that hiring data analysts is easier than data engineers or data scientists because it's easier for us to quickly get a feel of how that person would perform.
So in most contexts that I'm familiar with, the data scientist is the one who will be paid the most because he or she is creating the most business value. Except for some specialized roles, say like at Facebook, Twitter, massive amounts of data that are just like completely pressing the world and technology's ability to deal with it all. Like these the data centers that Google's built up in Oregon that they're powered by solar and they've got these massive amounts of RAM because you just can't access the data fast enough off of any kind of storage. That kind of data engineering, there's a data engineering aspect of that, like organize the world's data, make it valuable. Like if you're that data engineer, that can be a harder problem to solve and a more highly compensated role than the folks who then just model that data. In general, though, the data scientist is a combination of, or the analyst, the engineer, and like those are all part of the data science skill set. Generally, we pay that the most.
One of the questions that I always get in this group is technology. Like, what is the next thing? Because folks could be learning things like back when I started, it was random forest was the hottest thing, and then the HD boosting came in, deep learning now, and all that. So, what do you? And now there's things like blockchain and AI and natural language processing, which has been around for a long time, but it's getting more ramped up. What do you think is the next technology that a data scientist needs to critically know for the future, for their career?
One that doesn't exist yet. It's called model interpretability. That's where we're putting our money. AutoML, you're gonna love that. Machine learning is a solved problem. With the advent of AutoML as a service, we are finding fewer and fewer cases where general modeling, machine learning techniques are necessary. I mean, you can just use AutoML, let that baby run in the background and come back in a week. It takes a really specialized question to be be beneficial, to use some crazy deep learning model that's developed by a custom builder team. So I think that the thing that's coming up in 2022 is the ability to interpret our models in a more meaningful way. And those tools don't exist yet. So if you want a job, build that tool, open source it, and then share it with recruiters.
What do you think is the next technology? Any one of you guys?
It's a crystal ball. This field is so fast moving. Frankly, no projections. But basically, just get a hold of what is there out there right now, and then make sure you at least master one, so that you have definite expertise in one area.
Anybody have any questions here? Okay. Well, anybody else that hasn't gone? No?
My question is, how do you handle failure? Like, you scope a project and you believe that you would get a result, for example, in oil and gas, that you think that you'll find the well that has oil in it, but you fail it with all your AI and machine learning projects. So how do you explain that to a client? Or how do you go forward from that?
So good question. I think the most important thing is to scope things. To be very thoughtful about how you scope a project. We're extremely thoughtful about what companies we'll work with, what companies we want as customers. But look, I mean, this is experimental. Not everybody gets everything virtually no one gets every answer to every question that they want from the data. That said, virtually any competent team who has properly diligenced the data and the company, the system before committing to a project and a significant piece of work, should be able to find something meaningful. We define an insight as something that wasn't previously known and that is valuable. We haven't failed to produce at least one or several meaningful insights. That's not to say that we've created the same amount of capital efficiency optimization for every company we've worked with. But if projects are thoughtfully scoped and appropriately staffed, there should not be situations where truly where value is only destroyed and nothing new is found from the data. If there is, get as far away from those people as you can and don't look back.
Hello. I keep reading these articles about how data science demand is a bubble, and maybe like in a couple of years the demand has peaked, and then the data scientists will no longer be in a demand as they are in right now. So do you have any comments regarding it, or is it like a field which is perpetually like keep growing?
That article's wrong.
Yeah. I mean, the outlook that we have is that just data is massively exploding. People, and even companies don't know what to do with it. So it's just going to be unlimited demand. I mean, limited, but a lot of demand in the future. I agree, the article is totally wrong. And a few years ago, I mean, AI again is not new, right? It was there 30 years ago. And then there was an AI winter. But very unlikely going forward, there will be another AI winter type situation, just given the massive computing power, the ease of availability, and so on.
We have time for one more question.
Hi, you commented earlier that to be a data scientist or to work in these fields, you have to have passion because the work is just so incredibly hard and time consuming, the money alone isn't enough. So I was wondering if you could describe the work-life balance, just whether or not it's worth it to you, or whether or not it's worth it to someone who isn't highly passionate about this.
It's not worth it if you're not passionate about it. But that would be my answer if you'd asked me about software engineering or painting murals on the sides of buildings. I mean, I guess this is going to sound privileged, but I feel like if you're considering getting into this career track, you should do it because you enjoy combining the creativity it takes to do this work with the technical competence you need to accomplish the goal.
Yeah, I agree. I mean, unlike traditional work streams, a lot of surprises can come forward. And addressing the earlier question, so we try to limit those surprises for both the client and for us by structuring projects as POCs, proof of concepts, so that we don't go haywire. At the same time, we can help our teams progress in a structured way which gives them work-life balance. But having said that, things still go haywire because it's just many unknowns. And so you have to have the passion. So if you want to go into this field, you make sure you love it and sort of you are energized by it.
So the best career advice I got from my father that I didn't ignore was to choose the job that I thought I'd like the most, not the one that I thought I'd make the most money at or something. And I challenge everybody: find me someone who's truly great at something who doesn't love it.
Cool. So in conclusion, to close us out, we usually, in these forums, we all come here and want to take something home that's really, really valuable. We have 3 people that are here that have a lot of experience and have a lot of knowledge. So I'm going to give them a chance. It doesn't have to be data science, demystifying the data science process, but do you have something that you can tell us that we can take home as a nugget to say, hey, I know this guy talked about automation or blockchain or whatever. Can you, in 5 minutes or so, can you tell us something that's very valuable that these people can take home with them? It doesn't have to be, whatever, I'll leave it up to you.
So for me, it's, people say, so either are you a generalist or a specialist? I think my viewpoint is you got to be both. You got to see the big picture, you got to see the forest, and then you got to immediately zoom down and see the trees. Because especially with data, and as you become data scientists and look at the data field, it's the power of one that's very important, and that one accumulates to become a big data set, which then gives you an overall picture. So forest and trees all at once.
You gave me an extra. So because a lot of the questions we've got focused on the getting into the field and trying to figure out how to do data science, I'll attack this question from that angle by giving you a couple of concrete recommendations. Number 1 is R is dead, learn Python. Number 2 is, since you're already learning Python, start playing with scikit-learn. And the reason is because all of the models in scikit-learn follow a common syntax. So what that means is if you are interested in the theory behind the models you're building, and you should be if you want to jump, you can play with the models very easily in scikit-learn, swap them in and out, and see how the results change. And because, again, you're already in Python and you're already using pandas to deal with your structured data, you can also alter the data pipeline to see how the results come out and maybe even correlate your inputs to your outputs. And in practice, the way that you do this is by using open source stuff. Not just data, open source data, but also open source Python, scikit-learn projects. To just take somebody's code off of GitHub and break it and figure out why it's broken and how to fix it and maybe build it again in a way that was different than what the original author did. And then republish it because somebody else can learn from it. And typically when you republish stuff on GitHub, people will comment on your code, which is kind of terrifying. But you learn to become better that way. So that is the three-step process to getting into this field, in my opinion, as a green bean. And when you do that, you automatically also build up a portfolio of work, and then you can showcase that to employers.
Great. So it's a lot of pressure, man. It's a big topic here. There's a couple things I'd share that from my experience, I've found helpful. You know, coming out of school, kind of looking for the initial starting jobs, I kind of had a tendency to just like look for. I didn't put a lot of thought into what I really wanted, and just try to kind of approach the job market as more of a chameleon and kind of trying to present myself as what I thought they wanted. And most of that didn't work out very well for me, and I'm really, really grateful it didn't. My experience has been jobs select us as much, if not more, than we select them. But that said, I found it incredibly helpful to actually, for me, putting this down on paper. Obviously, this is harder to bullshit myself if I write it down. Who do I really want to work with? What, people-wise, kind of schedule-wise, culture-wise, what's really important to me? Really actually write down on paper, like, what are my values, the things I don't want to compromise on, and, what am I just not going to compromise on in the workplace? What's a nice to have, what's a need to have? Then have some kind of sense of, where I'm going, what kind of company is it going to be, who are the people going to be? I can tell you from a retention standpoint of our senior data scientists, and I don't think anybody in this room would guess. Is anyone going to try and guess what the most important things are to our senior data scientists? Anybody? Money, stock?
No deal.
Yeah. Very important. It's being able to bring your dogs to work. I didn't know. I like dogs. I didn't do this as this wasn't like a business-driven decision for me, but they're like, oh my God, you can bring your dog to work. It's like this huge thing. I don't know if that scales indefinitely or not, but that's really important to some people. If that's really important to you, it's important. I find it really helpful to put that stuff down on paper in a tangible way, and just keep that in mind. You're more likely to find a good job, and you're more likely to be successful with the employer that you find that fit with.
Okay, very cool.
And by the way, Francisco, thanks so much for having us, and thanks for the great questions.
Yeah.
I've spoken at panels like this, and there's like nothing worse than looking at this huge room of just like these blank stares. It's like actually really fun. So thank you all.
Yeah,
thanks
guys. Couple of announcements. If you have, you want, we can. By the way, you guys gonna hang out for a little bit.
Yeah.
So raise your hands. Who's hiring again? Those guys. Okay. Please take whatever they can give you. If you guys want to talk to them, they'll tell you a little bit more what they're doing. Also, if you have your parking, you want your parking validated, you park at the parking space, go see your dad in the front. Okay. And go ahead and get pizza, whatever. We'll hang out for another 30 minutes. Thank you very much and have a good night.
Cisco, that was awesome, man. You got a great
I have it on YouTube. Hopefully, I don't think I'm doing